Hello guys. I hope you are good from wherever you're watching us from. We're doing our paper 1 mathematics for grade 12 in preparation for our trial exams. So we've already covered calculus. We did the whole 35 marks of calculus within only 20 minutes. If you haven't checked the video, check it out down here on these videos. So now we are looking at the concept of functions. So just to give you a quick recap before we go deep into functions, what is important is to understand that when we are looking at functions, we've been taught functions since grade 8, but now we are writing our trial exam. So how can we do grade 8 to grade 10, grade 11 to grade 12 and cover it in a short period of time? So this is the trick. What is important is to understand that you have been taught about a straight line function where the domain is always x is equal to the element of real numbers and the range is y is the element of real numbers. Then in grade 10 now we introduced a parabolic function as well as a hyperbolic function, and an exponential function was introduced in grade 11. Now we are looking at the asymptotes of a function. We are looking at where the graph cannot touch, where and what. So those are the things which you just have to remember. And you must always remember that when you're plotting your function, always calculate your x-intercept, you always calculate your y-intercept. Then after that, what do you do after that? You just plot your function. So this is what I want us to do and look at. So you can see that we are looking at the preparatory exam or the trial exam, which was written last year. So let's get into it. Let's dive into it. If you have any question, drop a comment on the question on the comment below, or you can join our WhatsApp group on the description of this video. Then you can be able to ask your question anytime, any moment which you have your question. Let's get out to the question which we have for today from the paper which was written last year. So now they say in the diagram below, the graph of a hyperbolic function. Oh, this is a hyperbolic function. What do we know about a hyperbolic function? We know that a hyperbolic function, it has a horizontal and a vertical asymptote. Oh my word. We are already done. We are already done solving our problem. So if they ask us about the domain, you know that the domain is x element of real numbers, where x is not supposed to be equal to the vertical asymptote. What's the range of the function? Y is the element of real numbers, where your y values must not touch the asymptote. Then now they're saying where k is a constant and it's drawn on A, which is 1:0. Where is A? I can see A. We can see A is the x-intercept there. Then after that, the B is the A and B, they are the x-intercept, and B is the y-intercept of F. You can see that B is the y-intercept, but we don't have the coordinates respectively. Then we have a vertical asymptote which goes through x-axis at 3. Oh my word. Write down the value of P. What's P? P will always be our vertical asymptote there. So that's easy, guys. I'm sure everyone knows how to do this problem, because we're just looking at our vertical asymptote. So we are given that our asymptote is equal to x is equal to 3 there. So which means when you reverse it back, it's gonna be x is equal to -3. So what is the value of P? P will be equal to -3. Thank you. Now determine the value of K. So originally they've given us this nice ugly function and they said, oh, okay, the function is like this. We are given f of x. So this is what? 4.1. This is now 4.2. So they gave us something ugly. They say, okay, f of x is equal to x plus k all divided by x plus p. Okay, so we now know the value of P, that it's -3. Then they also give us the coordinates 1:0 of A. So we know that this is our X, this is our Y value. So let's come on here and let's substitute here. So f of X and Y, they are the same. So we have 0 is equal to, where there is X, we put 1. So it's going to be 1 plus K all divided by 1 minus 3. So 1 minus 3 is -2. Then we cross multiply that. That will be -2 times 0 equal to 1 plus k. Wow. Then we have 0 is equal to 1 plus k there. Then after that, we can see that our k is equal to -1. Without wasting much time, now here we go. We have our 2 marks. Now calculate the coordinates of B. Where is B? In the statement, they've already told us B is the y-intercept of F. So now let's go to our f of x first. So this is 4.3. So our f of x now, after we've solved, it is equal to x minus 1 divided by x minus 3. But now they're saying calculate the coordinates of B, but we know that B is a y-intercept. So which means that this is 0 is to y. So we just have to calculate the value of y, and where there is x, we place a 0 there. So we come here and say 0 is, we say y is equal to, where there's x, we say we place a 0 there, then minus 1 divided by 0 minus 3. Then y is equal to negative 1 minus negative 3. Then our y is equal to positive 1 over 3. So we can literally see the coordinates of b will be 0 is to 1 over 3. You don't have to substitute and replace it with decimals to be 0.333333 and recurring. You can just say it's 1 over 3. You still get your full marks. Determine the values of x for which x times f of x is less or equal to 0. Nice question. This is for us to think. So in other words, they just want us to look at this question and be like, oh, okay, this is what they want. So x times f of x must be less or equal to 0. This is already is. So if you have time, you can literally solve this question and be able to see which row or where is our answer located at. So when you just say x times, of course, our answer is straightforward there because 4.4. So they want to look at where x times f of x is less or equal to 0, which means our f of x is multiplied by x. So you can just do that on your own spare time and find it. But me, looking at the graph which we have and just multiplying by x, I can see that definitely there I'm going to have x less or equal to 0, as well as between 1 and 3. We can literally see that's where we'll be able to find our values for which they will be following under that. So someone will be like asking, no, why did you say that? So you can still say solve it as I said. So this will be what? X times, what was our f of x? Our f of x is x minus 1 divided by x minus 3. Then we multiply, then less than or equal to 0 there. That will be x squared minus 1 divided by x minus 3, let's say equal to 0. Then after that, playing around with your inequalities, then definitely you'll be able to get these two values. Of course, you can see the one between 1 and 3. Then you can see also x must be less or equal to 0. Then boom, we are good to go. Rewrite the equation of f in the form of f of x equal to a over x plus p plus q. Guys, now they are telling us how to solve this problem. This is straightforward. Let's go. So this is 4.5. F of x is equal to x minus 1 divided by x minus 3. So after that, what do? We can literally say x minus 3 plus 2, ne? Divided by x minus 3. I mean, like, this can make more sense. I mean, negative 3 plus 2 is going to still give us negative 1 there. So now we can now divide everything through so that we can get a proper answer. So we can literally say that x minus 3 divided by x minus 3 plus 2 divided by x minus 3. Then this is just 1. Then we have 1 plus 2 over x minus 3. But like we should write it in the way they've gave us. So f of x now will be equal to 2 over x minus 3 plus 1. Then bingo, we are good to go. So we're able to rewrite this question to the format which they wanted us to rewrite in. And still we were able to keep ourselves happy. And we are really, really happy with the question and the way we have answered the question. Maths is nice, 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 nice. Tell your friend that maths is nice. Now, given the function f of x, now we're on question number 5. Given the function f of x is equal to negative 3 to the power x. Oh, what's the name of that function? It's a exponential function. So now we are on question number 5. So we are given f of x, which is equal to negative 3 to the power of x plus 1. Wow. So since they've given us that, how can we play around with that question they've given us? Now, they say, draw f in your answer book, clearly label your horizontal asymptote there. This is easy, guys, because now we already know what we are looking at. We already know our question at stake here. We know that this is a exponential function here, guys. So what is important is to understand that our y is equal to 1, which means this is our horizontal asymptote. Horizontal asymptote. Okay, why? Because we are taking this here. Okay, that's our horizontal asymptote. Then after that, we can now find our x and y values. So of course, our x-intercept there, that would just definitely be what? Y equal to negative 3 to the power x plus 1. So x-intercept, we should let y equal to 0. Then this will be 0 is equal to negative 3 to the power of x plus 1. Then we have 3 to the power of x is equal to 1. Then definitely 3 to the power of x is equal to 3 to the power of 3 to the power of 0. I mean, 1 is the same as 3 to the power of 0, then our x is equal to 0. So now you'll be able to appreciate what you were doing when you were playing around with those exponents. Like, in the meantime, I was like, this is boring. But now you can now appreciate our exponents, which we have taught in grade 11. Then now we can still calculate our y-intercept there so that we can be able to plot our function properly. So y-intercept, we just let x to be equal to 0. So this will be y equal to negative 3 to the power of 0 plus 1. Then anything to the power of 0 is equal to 1. Then this is probably 1. A negative 1 plus 1, it's 0. Wow, so we have a coordinate at 0 is to 0. So now we just plot our function. Here is our function. Then we say that we have a horizontal asymptote at y equal to 1. We plot our y equal to 1 here. So this is y equal to 1. This is 1. Then we have a coordinate here. Then we say that it is a horizontal asymptote, which means our graph should not even touch the asymptote. Then here we go. Done like that. Just like that, we are ready to live our best life. 3 marks in our pocket. Now write down the range of the function f. So the range is always the y value. So we are looking at the y-intercept of the function so that we can be able to determine the range of the function. So we can literally see that our y must always be less than 1. You can see that our function is not even touching the asymptote, so which means our function must be less than 1. Or someone will say that it should be y element from negative infinity to 1. Okay, so when we just use that bracket without an included bracket, which means it's not touching 1, but any value, maybe 0.9999, it's part of the function, but not 1. 1 is not included in the function. So there we go, and we are happy. Determine the equation of the asymptote of g, given that g of x is negative f of x. This is easy. Okay, so now we have given g of x, which is equal to negative f of x. So what was our f of x initial? It was negative 3 to the power x plus 1. Then this will be 3 to the power of x minus 1. So this is our new function g of x. Then they said that write the equation of the asymptote, which means now our equation will be y equal to negative 1, because we look at the value of q. So the horizontal asymptote, our new horizontal asymptote is equal to y equal to negative 1 there. Then after that, on 5.4, come on here with me. If g is shifted 1 unit upwards, okay, to give a new function h, determine the equation of h inverse, the inverse of h in the form of y. Oh, okay. So if g is shifted 1 unit upwards, okay. This sound amazing. So g of x now, which is equal to 3 to the power of x minus 1, now it has been shifted to form h of x, and it has been shifted 1 unit upward, which means it's going to affect the value of q. So 3 to the power of x minus 1, and it has been shifted 1 unit upward, so we add 1. So this now will be h of x is equal to 3 to the power of x. Okay, because negative 1 plus 1 is equal to 0. Then after that, we now calculate the inverse. Of course, this is y equal to 3 to the power of x. Then we interchange. Then we have 3 to the power of y. Then we solve for y. The log of 3x is equal to y. Then therefore, h inverse, or the inverse function of h, is equal to log base 3 times x. Then after that, you have your marks. So here we go. Here is our function. If you have any question again, don't hesitate to ask us anytime, any moment. Danko, have a good night.